Hello everyone, let's talk about, let me change my pen here. Let's talk about 1.05 quiz. This will be number 3. So I've gotten a lot of questions on 3 and 5, so I'm going to go over 3 in this video. Okay, so remember when we talked about temperature in the gas laws, it has to be in Kelvin. Why? Well, think about this. Celsius, Fahrenheit, do they go into the negatives? Do we have negative 12, which is right outside here, Fahrenheit? Yes. Do we have negative Celsius? Yes. When we look at our gas laws, let's say Charles, right? Charles, V1 over T1 equals V2 over T2. What are we going to do if our temperature is 0 Celsius? Can we have 0 on the denominator? No. We have to be in Kelvin. That's just an oversimplified reason to think about it. 0 Kelvin, that's absolute zero. Nothing is moving at that temperature. So we wouldn't have to worry about the gas laws, right? Because nothing's moving. So just think about that when you think, okay, it has to be in Kelvin. So let's go ahead and let's look at this. So first, let's just go ahead and let's do it in Celsius, right? You're going to see, where's my number here? So we have 30 degrees Celsius. So we have our temperature, we have our pressure, right? So we're missing our volume. So remember, no temperature is boil. Charles is under pressure, so that would be no pressure. So that leaves Gay-Lussac's. So volume's held constant here, which, and let's do, so Gay-Lussac's P1 over T1 equals P2 over T2, right? So identify your variables. So here is our temperature one. Here's our pressure one. We decrease the temperature, so temperature 2, volume's held constant. What's the pressure? So this is P2. Now, we know that they're directly proportional, right? If one goes up, the other goes up. One goes down, the other goes down. So, look at the difference here, just to look. 30 degrees Celsius to 10 degrees Celsius, right? That is a decrease. Right, it 10's about 1/3 of 30, right? So it decreased by 2/3, right? 66% decrease. Okay? Well, we have to be in Kelvin. That's a huge decrease, right? Huge. We have to be in Kelvin. So let's convert our Kelvin. 30 plus 273 is what? 303? So we are in 303 Kelvin is our T1. Our T2 is what? 10 plus 273, 283 Kelvin. Now look at it. What percentage did we decrease? We didn't decrease by 2/3, right? We didn't decrease by 66%. I did it earlier. We decreased by 7%. Okay? There's a huge difference when we're looking at Celsius versus Kelvin versus Fahrenheit, right? So we need to make sure we're in Kelvin. So those of you who missed this and said it reduced to 1/3 of what it was, or it reduced by 2/3, temperature did if you keep it in Kelvin, but we can't keep it, or keep it in Celsius, but we can't keep it in Celsius. We have to convert to Kelvin. So what happened then to the pressure? It didn't decrease by 2/3 or decrease to 1/3 of what it was. It decreased by 7%, okay? Because that is what our temperature did. Our temperature in Kelvin decreased by 7%, okay? So hopefully that helps. Look at it. That's why you always have to be in Kelvin when we're talking about temperature. The other ones, as long as you're in the same units, you're fine. So this is kilopascals. We could have been in ATM. That would be fine. Volume, as long as you're both in milliliters or both in liters, that's fine. Temperature is not. Right? Remember, we can't have a 0 on the denominator, so we have to be in Kelvin. So then just to go ahead and do it for you. So our pressure, what do we say originally, is 101.5 over our temperature, 303, and that's equal to, we're looking for our pressure 2 to 283. And so then X is equal to, let me play it out here. So 283 times 101.5 divided by 303. So that gave me 94.8 kilopascals. right? So then you could divide it, 100 minus, whatever. You can easily tell, before you even did it, you could tell it's going to reduce by 7% because you could look at the actual temperatures here. Okay, so hopefully that helps on that. Remember to make sure you're in Kelvin. Any questions? Let me know.